Hey guys, we're going to talk about two-dimensional kinematics. I thought we'd hit a couple of examples from your notes packet, most notably example 6. So if you want to have your notes packet out and flip it to the page where example 6 is, that might be helpful. Before we do that specific example though, we're going to look at a couple of bits of information about just how you do two-dimensional kinematics in general before we attack any specific examples. So let's start off with the steps. Number 1. Write equations for delta x and delta y. That's where you want to start. Okay, so rather than thrashing around, drawing a diagram, writing down some random numbers, write out a framework that you can put things into. That's your delta x equation, always for two-dimensional motion, since we're not dealing with rockets that accelerate horizontally or beach balls in the wind or something like that, right? There is no horizontal acceleration because gravity is only a vertical force, right? It doesn't accelerate you in the horizontal direction. Your delta y equation is always going to look like this. And the acceleration is always going to be your favorite negative 9.8 number. All right. Plugging in what you know is the second step. Now, sometimes that's like numbers they give you in the problem, like the projectile goes 12 meters before it hits the ground, or the building is 40 meters tall, which would mean the displacement would be negative 40. Okay, something like that. For the velocities here, though, that's the part that I find people usually have the most trouble with, because in the question, it often gives you like the speed and the angle. And often people will just like plug in the speed right here and don't bother with components. All right. Or maybe you don't know the speed, but you do know the angle. And so even people that know I need a number here kind of end up thrashing around because you don't actually always know a number. Okay? So if all else fails, though, you can always say that if this is V naught and that's theta, the x component is V naught cosine theta, and the y component is V naught sine theta. So even if you say don't know V naught, but you did know like the launch angle, you could put something in, and something would be better than nothing, and then you can go ahead and problem solve from there. Last step is solve, that's pretty generic, which may include some substitution. So if you had it set up in such a way that like you didn't know t or delta x, you can't get there from here. But presumably if you don't know those two things, you have enough information over here that you can like find the time and then plug in over there. All right, so that's a general setup of like how a lot of kinematics equations are going to begin. So start with these two equations, plug in what you know, and then follow the math and see where the answer ends up. All right. The specific example that I wanted to look at from the notes packet is example 6, which looks like this. So if you need to pause the video and read the text, go for it. But the basic idea is you've got some guy on a motorcycle who thinks he's really awesome. He probably is really awesome. Let's give him the benefit of the doubt. All right, and he goes leaping off this ramp on his motorcycle and lands on the other one. Okay, this is 5.3 meters up, 4.8 meters up, seems excessively tall, and they're 5.1 meters apart from each other. And we don't know the initial speed. Okay, well, let's write out what we do know. We know we're going to use this equation. We know we're going to use this equation. And I do recommend writing them side by side. If you do that, the math is usually a little bit easier to organize. All right, we know the horizontal displacement, assuming he makes it, is going to have to be at least 5.1. So let's throw in 5.1 there, right? We'll assume that he just barely makes the leap. All right, V naught x is actually the part where most people are like, abandon ship, I have no idea, because you don't know V naught. Okay, so you can't put in a number. That is no reason to panic, and here's why. The algebra is actually going to help. The algebra is going to allow us to solve for v naught, even though we don't know a number for v naught x. Rather than put in nothing or just put v naught x again, what we'll do is we'll say that v naught x, since this is a 30-degree angle, v naught x is v naught cosine 30, which means that it's approximately 0.866 times whatever the initial velocity is. And that is something that we can plug in there. That's a lot better than nothing. And then, of course, we don't know the time. They didn't tell us how long he was in the air for. All right, same thing for v naught y. We can say that that's v naught sine 30. Sine 30 is 1/2, so that means that we would say 0.5 v naught for v naught y. Okay, so we don't know the initial y velocity or the initial x velocity exactly, but we can talk about them in terms of what proportion of v naught they are based on the angle. All right, so over here then, v naught y will be 0.5 v naught. Still don't know time. Acceleration's negative 9.8, so half of that would give us negative 4.9 t squared. All right, delta y. Based on my picture here, I'm not going to use either of those two numbers there. Right? Neither 5.3 nor 4.8. The difference in height is a ½ meter, but he's landing lower than where he started. So that means that we would want to put in negative 0.5 for his y displacement. Okay. Well, you might look at that and say, oh crap, there's two unknowns in that equation. Oh, there's two unknowns in this equation. I don't know what to do from here. All right, there's a couple of different ways that you could go algebraically, but both of the ways you could go involve using substitution. In math class, if you had an equation that was like 2x plus 3y equals 5, and then 3x minus 4y equals 6, right? You wouldn't just say, I can't solve for x and y. I have two unknowns in both equations. I'm stuck, right? You're not stuck. You can use, in this case, substitution or elimination in order to solve for both x and y, right? You could take this equation, you know, get the y on one side and say x equals something or other in terms of y, and then plug it into the other equation. In this case, I'd probably use elimination. Who cares? Whatever. The point is, it doesn't matter that you have two unknowns in every equation. You can solve this equation for, like, v naught, and it won't be a number, but it will be something that you can plug into the other equation that will allow you to easily and conveniently get the answer. Okay, so v naught would be 5.1 divided by 0.866 t, or if we like, we could say that that's 5.889 t. Over t. All right. That's not an answer, but it's something that we can sub in over here. All right, so now I'm going to take that, plug it in over there for v naught, and we have something that we can work with. All right. So if at any point here you need to like stop the video so that you can slow down the algebra, that's of course just fine. Or if you go back and look at the answer key for this question, you know, you can see the algebra in there as well. Okay. I think I solved it a different way in the example pack that I posted in Google Drive. That's fine. There's more than one algebraic way you could do it. Okay. I could have taken this equation and solved for t, okay, and then plugged that in for t in both of the places it is in the delta y equation. That way it actually ends up being more nasty in terms of the algebra, You could do it that way. There's nothing wrong with it. You will get the right answer, but the algebra is a little bit simpler here. All right. This will simplify to actually just a number because the t's cancel out. Works out to be 2.944 approximately. So yes, 2.944 approximately. All right. Now, if we want to solve for the time, subtract 2.944 from both sides. This will now be negative 3.444, which is an awesome number. Negative signs cancel. We divide both sides by 4.9, which gives us 0.703 equals t squared. A square root later, we get that the time is 0.838 seconds. All right. Now, if you lost like the focus of the problem, because lots of algebra happen, the question asked us what the initial velocity of the guy was. Okay, so this isn't actually the answer. This is just how long he's in the air sailing towards the other ramp. But once we have the time, we can take that and we can sub it back into that equation. All right, and so now we have 5.889 divided by 0.838 will be our initial velocity. And that gives us an initial velocity of 7.02 meters per second. Okay, so that was this daredevil's speed at the moment that he left the end of the ramp. Okay. I think that's everything in terms of what you need to see here. This one was involved in the algebra, right? Or at least a little more involved than some questions are going to be, right? What made this tricky or interesting is that we had two unknowns in both equations, but note that wasn't actually an insurmountable hurdle, right? If you know your algebraic tools like substitution, it's okay that at some point you get just an expression for something if what you can then do is take that expression and plug it into the other equation and eliminate some variables. So if you can get one equation down to only one variable, then you can solve for everything. Okay? If you have any questions, don't email me, that'd be fine. Or take a look at the notes that are posted in the drive. Okay, thanks very much.